This is our third video on oscillations and waves, and I will continue practice questions in this video mostly. So we're going to look at some of the questions that are given in your lessons and how to solve them. So in this video you have a 0.4 kilogram mass attached to a horizontal spring that goes under simple harmonic motion with a total energy of 0.2 joules. So the total mechanical energy always stays to 0.2 joules. And the potential energy as the function of position presented by the graph that shows on the right. What is the amplitude of the oscillation? And from the graph you see that the maximum displacement is -5 and +5 centimeters. So the amplitude is 5 centimeters or 0.05 meters. So that is your amplitude. The next question they ask, what is the spring constant? And I can use the maximum potential energy is equal to 1/2 kx squared and equals to 0.2, the maximum energy that is given. So if I times by 2 both sides, I have kx squared is equal to 0.4. And they ask you for the spring constant, so that's k. So k is equal to 0.4 divided by x, that's the maximum displacement, which is 0.05 squared, and I get k is equal to 160 newtons per meter. For C, they ask what's the kinetic energy of the system at 2.5 centimeters. So I can calculate the potential energy at 2.5 centimeters, and then the rest is going to be the kinetic energy because the total energy of the system is 0.2. So my potential energy of the spring at 2.5 centimeters is equal to 1/2, and then it's kx squared. K is 160, and if I convert 2.5 centimeters into meters, that's 0.025 squared. So that's 1/2 kx squared, and that will give me 0.05 joules. So that is the potential energy, and the total energy that they give you at the top in the description in the statement of the problem is 0.2. So the kinetic energy is the rest of it. So that is 0.15 joules of energy. And then for D part, they say indicate point or points where the kinetic energy equals the potential energy of the system. So if the total energy of the system is 0.2, then the kinetic energy is equal to the potential energy of the spring when both of them are 0.1 joule. So, and they ask me where exactly that will happen. So if I set this equal to 1/2 kx squared, I can find where x is. So if I plug in 160 for k and divide 0.1 divided by 160, and then I take the square root of that number, I will get that x is equal to 0.035 meters. In other words, at 3.5 centimeters, the kinetic energy is going to be equal to the potential energy. And then for the last part, they ask you, what is the maximum speed of the object? The maximum speed of the object when the kinetic energy is equal to the maximum energy, which is 0.2 joules, and equals to 1/2 the mass and v squared. And the mass is given, the first line of the problem is 0.4 kilogram. So I have 1/2, the mass is 0.4, v squared is equal to 0.2 joules. And if I solve this one for v is going to be equal to 1 meter per second. So the maximum velocity will be when the potential energy of the spring is equal to 0 joules. That's when the kinetic energy is maximum, and the velocity is going to be 1 meter per second. Let's look at this question. A 20 gram piece of clay moving at the speed of 60 meters per second strikes a 500 gram pendulum bob at rest. The length of a string is given. So let me maybe highlight everything that's given. So the mass of the bob is given. The clay is given. So this is the clay. This is the bob, the pendulum bob, and the length of the bob is given. After the collision, the clay bob system starts to oscillate as a simple pendulum. What is the speed of the clay bob system after the collision? So for the first part, for A, I can do momentum before, momentum after. So I have, let's call the clay m sub 0, v sub 0, that's the initial velocity, plus the mass of the bob, velocity of the bob. And then after they stuck together, so I have the mass of the clay plus the mass of the bob and their velocity after, the one that they asked me to. So now if I plug in the mass of the clay, 0.02, velocity of the clay that is given 60 meters per second, plus the momentum of the bob, which is 0, and after they stick together, so that is going to be their mass together, which is 0.52, and I'm looking for their velocity after. So if I plug in my numbers, I will get the velocity of both of them after is 2.31 meters per second. And again, momentum is always conserved, so I can always use momentum even if there was no energy conserved. Then for B part, they ask you, what is the maximum displacement of the pendulum? So for the B part, I need to find the kinetic energy to the potential energy. So the kinetic energy of the bob after the collision is 1/2. It's their mass together because they're still stuck together right after. And their velocity is squared. And when I say the velocity, I mean the velocity that I just found. And that is equal to the potential energy, which is their mass together, and G. And they ask, what is the maximum angular displacement? So if I find H, I can talk about the angular displacement. So the masses can be canceled from both sides. And then if I solve for H, I will get H is equal to 0.27 meters. So 0.27 meters. And I think I need to draw it. So if this whole thing is 0.8, so this is where the bob was before the clay got stuck to it. Now the bob is gonna be in this position somewhere with some clay stuck to it. So here's the bob and clay is stuck to it. The height, this one, is the one that I just found. So this is the height. And the length of the string is 0.8. If I look at this triangle, then this is right angle. And this part is 0.8 minus H. So if I need to find the angular displacement, or this angle theta, I have adjacent and hypotenuse, so I can use cosine. So I'm gonna say cosine of theta is equal to 0.8 minus h, the adjacent, 0.8 minus h, which is 0.27, divided by the hypotenuse, which is 0.8. Then theta is equal to arc cosine, or the inverse function of cosine, and that number is 0.53 over 0.8. So I have 0.53 over 0.8, and that will give me the angle of 48.51 degrees. So that is the angular displacement of the bob. The next question is, what is the period of the clay bob oscillation? So it is a pendulum, so it has the period formula of 2 pi, the square root of L over G. So I have 2 pi the L is 0.8, the length of the string, and G is 10. So if I plug in my numbers, then I will get 1.78 seconds. So it takes to go there and back 1.78 seconds. For D, they ask, what's the total energy of the oscillation system? So for D, to find the total energy, I can do potential or kinetic energy, it doesn't matter. So I can say that's 1/2 m, and I'm talking about the V that I found in A squared, and that is equal to mg, the H that I found in B part. So if I plug in my numbers, oh, and the M, it has to be a mass of both. So here I fixed it, and if I plug in my numbers, I will get the maximum potential and maximum kinetic energy is equal to 1.4 joules. So that's the total mechanical energy in the system. And then for E part, what is the maximum horizontal distance that the bob of the bob when it strikes the floor that is 0.7 meters below? Oh, the pendulum bob makes one complete oscillations, and then the string breaks and it falls down. So 0.7 meters below. So what I have is this. The bob is 0.7 meters above the ground. When the string breaks and the mass is attached to it, the clay is attached to it. When the string breaks, it is moving with the velocity of the one that we just found. That was 2.31 meter per second. 2.31 meter per second. And they say it is 0.7 meters above the ground. So this height is 0.7 meters. So I can find the final velocity because I know the height, and I can use the DAF formula from our previous videos. So the DAF formula is the square root of, when I know acceleration and the distance, 2 acceleration due to gravity, the distance, which is the height, and plus initial vertical velocity. There's no vertical velocity, it's moving on the horizontal velocity, the maximum velocity. I probably should say draw it this way. So the bob is like this when the string breaks, and so that's initial vertical velocity is equal to 0. And if I plug in all these numbers, I will get, and I should make sure that I write this H is different. It's not the H that we found 0.27 earlier. So my H is 0.7, so that's my H. So if I'm plugging in all these numbers, I'm gonna get 3.74 meters per second. So if I know the velocity is 3.74, I can find the time it takes to hit the ground. So the time is the change of the vertical velocity over its acceleration. So it starts with vertical velocity 0. The purple one is the horizontal velocity that we found earlier. So that is 3.74 divided by initial is 0. And divided by 10 gives me 0.374 seconds. So that's how long it takes to hit the ground. And if I want to know this horizontal distance where it lands, the distance, I need the horizontal velocity, which is 2.31 times the time. So I have 231 times the time, which is 0.374, and I will get the distance is equal to 0.86 meters. I believe this was a very similar question to the AP exam. Maybe it was even one of the released AP exam questions. I don't have the year when it was given, but this is what AP exam questions would look like. They would put a lot of different concepts in one question, and they will ask you, there's momentum, there's energy, there is angle, there is period of oscillation, there is maximum energy or total mechanical energy that they ask you to find. And they also see if you know how to find this distance based on like the the string is breaking and the projectile motion. So there's a lot of different questions in one question that you have to be able to solve. And also, you watch these videos and most of you saying, okay, I understand this, does not mean you will remember it when AP exam comes. So you have to practice these questions without looking at the notes and the videos. Videos will help you and explain to you how to do the questions, but you have to do your own practice so you understand more when you're solving questions, where the things that we're doing and where they're coming from. Here's a very similar question, and similar to what AP exam again might look like. So I'm gonna give you time to read it, so I don't have to read it and spend time on it. I want to spend as many questions solving for you as possible. So go ahead and read it, and then when you're done reading, after you paused it, maybe try to solve it on your own. You see, there's no numbers in this question, so go ahead and see what you can do, and then when you unpause and after you try to solve it on your own, we will do it together. And let's see if you solved it correctly. So I hope you paused and already unpaused and back to see if we can solve this question together. So the first I'm going to do is I have to find what is the speed of the system of 2 blocks after the collision. So I can do again conservation of momentum. Momentum before I have the mass with some velocity. So this is the information that is given, and the other mass is not moving. So I have the mass of the other object and its velocity is not moving. Then afterwards looks like they will be stuck together. So I have again mass plus the other mass and the velocity of both. So I can solve for the velocity of both. And let me call that velocity just v, so I don't have to write both every single time. So I have mv divided by m plus m. So this is my expression for a part. A lot of the question on AP exam, probably like 30-40%, you will not see numbers. You will have to derive the formulas, and formulas are not always the same as we did in the classroom. But if you learn to derive the formulas that we do in the classroom, you will be fine on AP exam. Okay, for B part, they ask you the amplitude of the oscillation of the system. So I can do the kinetic energy of both. So that means with moving with the velocity that we just found is going to be converted to the potential energy of both, or potential energy of the spring. That's going to be when the spring is fully compressed. So the kinetic energy of both is 1/2 their masses together, and the velocity that I just found squared, and that is equal to 1/2 k and x squared, and I can cancel 1/2 from both sides, and then what's given is the mass, the k, and velocity initial, and the small block is moving. Its mass is also given because it's mentioned right here. So the mass, the velocity, this mass, and k. So these are the quantities that are given. So if I want to solve for x now, I have x is equal to v, and that v is the one that we found earlier, this v. And I have m plus m divided by k and the square root of it. So now if I plug in this velocity that I found earlier, I have mv divided by m plus m, and then I have the square root of m plus m over k. So now I have this expression, and that is my x, the maximum compression. For the next question, they ask you to find the period of oscillation. So the period of oscillation is equal to 2 pi, and it's their masses over k, but the masses are together, so I have m plus m and K is given, so that's going to be the period of the oscillation. And then for D part, they ask what's the total energy of the oscillation system. So for D, I can say the kinetic energy is the maximum, or the potential energy maximum. So I could use the X, or I could use the V. So I mean the V or X to find the maximum energy, and I'm going to use the kinetic energy. So 1/2 their masses together and their maximum velocity squared. So it's this velocity, the one that I found earlier, squared. Now if I plug in my numbers, I have 1/2 the masses added, and then I have mv over m plus m, that's the velocity, squared. After I simplify, I get the I also can say total mechanical energy, or maximum mechanical energy, or the maximum energy of the system is equal to 1/2, and one of the masses can be cancelled, and then I have m squared v squared over m plus m. So that will be the total energy of the system. Let's look at this question as well. Very similar to what AP exam question would look like. Not necessarily the numbers are given. So that means this problem can be given without the numbers, just with the variables. So let's look what's given. A spring stretches, they give you 0.15 meters when 0.3 kilogram mass is gently attached to it. And then the spring is then set up horizontally with the 0.3 kilogram mass resting on the frictionless table. So frictionless table, the mass is pushed so that the spring is compressed, additional 0.1 meter, and released from rest. To determine the spring stiffness constant K, or the spring constant. So in the first question, they ask you to find the spring constant, but when they say that the mass is gently attached to it, they mean it's a vertical position. So if I have the mass attached to the spring, it will stretch by 0.15 meters. So what forces I have at this point is mg, and the force of the spring, which is kx. So for A part, I have force of the spring is equal to, the force of the spring is equal to mg, or kx is equal to mg, and k will be equal to, I get 20 newtons per meter, 20 newtons per meter. Then for the second part, they ask us amplitude of the horizontal oscillation, or A or X. So, and because they say that the mass is pushed so that the spring is compressed, 0.1 meter. So when it is horizontally, placed horizontally, so the first one was vertically up till here, and then from here it is now horizontally, and they ask you to find the amplitude. So the amplitude is that maximum compression, which is 0.1 meter. Then for C part, the magnitude of the maximum velocity. So I'm going to say the potential energy of the spring is going to go to the maximum kinetic energy of the block. So this is the block maximum. So I'm going to say 1/2 kx, which is a squared, is equal to 1/2 mv squared. And from here, I can find that the velocity is equal to 0.82 meters per second. Then they ask you to find the magnitude of the maximum, the magnitude of the velocity when the mass is 0.05 meters from the equilibrium. So that means for D, let me do it, D. I have the maximum potential energy of the spring with the maximum displacement A is equal to still some potential energy, because in this case the mass is still displaced by some distance 0.05 of the spring, and plus the kinetic energy of the block. This is the one that we're looking for the velocity. So I have 1/2 Ka squared equals to 1/2 K this time is x squared, and I'm gonna say x is that 0.05 plus 1/2 mv squared, and that's the velocity that they ask you to find. If I plug in the numbers, I can cancel all the 1/2s. If I plug in my numbers of K that I found earlier, A, and the mass that is given, the mass is given 0.3 kilogram. So if I plug in my numbers, I will get the velocity in this case is equal to 0.71 meters per second. I freed some space for myself. So, and the next one, they ask you the maximum acceleration of the mass. So for E, I can say that the force is equal to ma. The maximum force is acting when you have the maximum stretch, or the one that is 0.1 meters. So you have kx is the maximum stretch. So that is where the maximum force is acting, and that will give you the maximum acceleration. So that is equal to ma. So from here I have A is equal to K, which is 20, mass is 0.3, and or X is 0.1, K times X is 0.1, and M is 0.3. And this will give me the maximum acceleration is equal to 6.67 meters per second squared. And then the last question, in this problem, they ask you the total mechanical energy of the spring system. So for F, the total mechanical energy is the spring maximum energy, right? So that is how much, or the kinetic maximum energy, whichever it is. I'm going to choose the maximum energy of the spring. So the total mechanical energy of the system maximum is equal to 1/2 K and A squared. And that will give me 1/2 K, and A squared is 0.1 squared, and that is 0.1 joule. So this will be it for our third waves and oscillations video, and the links for the next videos are attached in the description, and I will see you in the next video. Thank you for watching this one.